अस्सलाम वालेकुम बिस्मिल्लाहिर्रहमानिर्रहीम रबिश वाली सदरी वयसरली अमरी वालुल उक़दतम मिन लिसानी यफ़क़हू क़ौली रब्बि ज़िदनी इल्मा. Okay, today we are going to discuss another important topic of our chapter number 4. Chapter number 4 that we started in the previous class, software, where we talked about the two categories of software and the definitions of software also, system software and application software, and then we talked about the different types of application software and their main features. So after that, we are moving to a very important topic, that is operating system. Now, when we talk about operating system, what comes to our mind? The very important operating system that we have in our computer is Windows. And similarly, when we talk about our mobile phones, we have iOS or we have Android. So these are also operating systems. And these are needed to make the systems work. If operating system is missing, so the whole system will be a useless thing. So here we can see the definition is to enable a computer system to function correctly and allow users to communicate with the computer. System software known as operating system is used. So this is the main definition of why an operating system is needed and what is it doing. It's there to make everything function properly. They provide in the environment in which applications or apps can run and enable a human computer interface. So what we interact with, it's all the operating system, or in short, we call it OS. And another very simple word that we can talk about operating system is it is the resource manager. Everything in the computer is a resource, and everything is handled by the operating system, or in short, we call it OS. Now, what are the main features, or you can say what is it doing? First thing is it's providing human computer interface, or in short, we call it HCI, multitasking, error handling, platform for running different applications, management of user accounts, managing files, hardware management, memory management, interrupt handling, security management. So let's talk about this is the whole, like all the functions or the operating system are present in the form of this whole diagram. So let's talk about each of them separately, and then we'll talk about that how the questions can come in our paper. So for that, we need to be very well aware that how the questions can come and how will we be answering also. Now moving to the first one, human computer interface. Now before I proceed to the discussion, do you know what is an interface? What is it doing? Interface is simply
The interface,
Mm,
like,
yes.
does it allow the computer to communicate with the user to communicate with the computer?
Exactly. So it creates a link between the two. So that is what it is needed to create a link or to help in communication. And when we come to the computer interfaces, there are mainly two, although there are others also, but for as far as your syllabus is concerned, or the main ones are HCI and graphical user interface GUI and command line interface CLI. Now, what is CLI? First of all, talk about this, giving you an example. If, for example, I drew a computer screen and I wrote the word monitor. So if I've, like, for example, if I drew the screen or if I drew the monitor, so definitely everyone who can just see will be able to understand that I'm talking about the monitor. Fine. But talking about if I wrote the spelling in English, so anyone who is well versed in English only will be able to comprehend what have I written. So that is what is the main thing between command line and graphical user. Graphical user is more user friendly because that is dealing with, or that is composed of icons which are easily understood, or easily the people can work on them faster, the people can work on them better, or you can say it is providing the user friendliness. But coming to command line, as the name implies, here the user needs to learn the commands. And if there is a spelling mistake that is being made, or if there is a space that you have forgotten to place, or if you have not used the proper grammatical rules, or if you have misplaced anything, then the work will not be done for you. And basically, command line has its own advantages. Like talking about this, everything has its own advantages and disadvantages. So talking about the features, user is in direct communication with the computer. See, when you talk about, like in the earlier chapter, we talked about the registers, chapter number 3. So with the help of CLIs, you can write such commands which will help in direct communication with the computer. The user is not restricted to predetermined actions. Predetermined, like the user can do something on his own also. Possible to alter computer settings directly. By the way, computer settings are normally not changed by us so frequently, being the users, but the ones who are well versed with the CLIs, they are changing the computer settings also, and this is all because of CLIs. Needs very little memory requirement. As far as memory is concerned, talking about the RAM, so CLIs need very little memory. The user needs to learn commands and must type them in using the correct format. So this is a very, you can say, a very clear disadvantage, I should say, or a limitation, I should say, because the users need to learn the command. So if you're not well versed with the learning of the format, then it will become a little difficult for you. Time consuming and error prone, always susceptible to making you make errors. User needs to have some understanding of how the computers work. So out of these, you can figure out these are all the features. So if I ask you write two advantages or two disadvantages, so I think we can very clearly talk about the advantages. Like the first one, direct communication with the computer. This is an advantage. User is not restricted to predetermined actions because he has more liberty. That is also an advantage. Altering computer settings directly is also an advantage. Needs very little memory management when memory requirement is also an advantage. But when it comes to the disadvantages, here we can see here there are a few limitations. As it is time consuming and error prone, you can say the user needs to learn the commands, the user needs to have some understanding of how the computers work. So again, you can see this is again a sort of a limitation. Not everyone is well versed with the working of the computer. So you can figure out very quickly, very easily from these points, these are all the features. If the questions are asked in the manner that right features, so you can mention any of them. But when they say write advantages or disadvantages, then you have to teach, you have to take it in this manner. Any questions?
No.
Now, graphical user limited to icons as shown on the screen. No need for the user to learn specific commands to carry out the actions. The way we said, CLIs need commands to be learned, GUIs do not need any commands to be learned. User simply needs a pointing device such as a mouse or a finger if a touchscreen is being used. An excellent interface for a novice or a user with limited knowledge. And this is what I said, user-friendly. GUI interface has considerable memory requirements. So this is basically a disadvantage. When you talk about icons, like you don't have much liberty. You have to just be doing whatever is available to you predetermined. You cannot can say, do anything on your own. Now, these are the two disadvantages. Talking about the advantages, you can figure out very easily that the rest are your advantages as you can see here. No need to learn the commands. User simply needs to a pointing device to be used, excellent interface for a user, and that is a user friendliness. So if the questions come in the paper talking about the write the features, or they say write advantages or disadvantages, then this is what you need to write. Another term that we need to know with respect to GUI is WIMP, Windows Icons, Menus, and Pointing Devices. And I mean, they can ask you, maybe in a fill in the blank form or in any manner, but you need to be very clear about the term WIMP or Windows Icons, Menus, and Pointing Devices, and then post-WIMP. And post-WIMP is because of the introduction of the touchscreens. Here we can see it's not restricted to Windows only. Now you have the feature through which you can perform the actions like pinching and rotating, which were not possible with your WIMP environment. So these are the few things that we need to know. I think we are okay with this whole concept. Any issues, any problem?
Everything's good.
Everything is good. Now let's move to the next one, memory management. Now, what is the memory management? Talking about so many programs are open. So what is an operating system doing? It's there to manage the memory properly, the primary storage. And if, for example, the data is moving between hard drive and RAM, that is also memory management. So it is keeping, now, for example, talking about us, like I'll compare it with the human being first. We humans, we have the memory management. That's why no two things get mixed up. I know that what I have to teach you, I know what I have to teach to the other student, when is your exam and is your test, etc. So this is all happening. I'm also keeping, and you are also keeping the different subjects in separate memory locations. Exactly the same thing is happening here in the computer. Different applications, if they are open, they all are opened in their separate memory locations. And the operating system is keeping a track of which memory is given to which application. And no two applications are ever going to use the same memory. Otherwise, there will be a chaos that is being created. And this is what memory protection. So that no two competing programs or no two programs are going to use the same memory. Like you may have experienced, if, for example, you have, just giving an example, you have some programming application open and you have your school work open, then the two things are separate. They never get mixed up. So this all is possible because of the memory management. Okay, no two things getting mixed up. Memory management means that keeping a track that which memory location is reserved for which task. So this is all memory management is about. Okay, and this agar, if that is not the case, then there will be a lot of chaos in the computer system. There will be a lot of problems happening in the computer system, and that is why memory management is a very important thing. Okay, fine, clear.
Yeah.
Now, next thing is security management. Now, what is security? You can see here, security means integrity, confidentiality, and availability of data. By the way, this topic you will study inshallah in under the heading of chapter number 5, where we talk about the security of the system also. What is happening here? Overseeing software updates when they become available. Software updates. Now, what is happening with software updates? Like, what is the advantage? When you talk about the software updates, what is happening there? If any new thing has come, so definitely software updates are going to be very beneficial. Any new updates that are there. So if you have the software updates, then your system or your operating system will be able to know about that update. If the updates are not available, then maybe a new virus has come or a new thing has come and you are unaware of it. So these latest versions or these software updates are always beneficial for the integrity of your system. You can see here, ensuring latest version of software is always being run, which often contains revised security fixes. So if maybe there was some bug that was found, or maybe there was some thing that was found in the previous version. So what the software companies do is they do float the revised versions so that those revised versions are having all the problems resolved. Running antivirus software and using a firewall to check all traffic to and from the computer. Again, antivirus, a very important thing that is needed to remove the viruses from the system. And again, a firewall is there to keep a track of all the incoming and outgoing traffic. Maintaining access rights. Sure, this is very important. Access right means what? Like, for example, giving you an example from ourselves. You have your bag. Maybe you may allow your friend to open it. That is access right. You will not allow every person to open it. That you are actually allowing only a few people to access, that is access rights. So similarly, in a network also or in a computer system also, you do give access rights to different individuals. You don't have full rights given to everyone. Carrying out data recovery and systems restore, and that is very important. In case of system failure, what will happen? System recovery, system restoring. That is very, very important. Understood? Security management
Yeah.
clear? By the way, this is same security management will be covered a little bit of it will be covered in chapter number 5 also. But here, if you have covered well, then you will be able to understand a little better. Now, next thing is hardware management. See, every single hardware component in the computer is under the control of the operating system. I mean, you can assume it just the way I said in the beginning, OS is considered to be a resource manager, and every peripheral is a resource. So, and every peripheral has its own device drivers, and these device drivers are actually under the control of the operating system. So, I'm not going to discuss in detail because we have just talked about it. But otherwise, you can see it manages the queues and buffers to ensure data is being handled correctly and that the CPU performs to its maximum. So optimum utilization of the system resources is what the job of an operating system is. Okay, any question?
No, it's good.
Is file management. So what is file management? Maintaining the file directories. And for example, if you give the file, if you give a certain file name, so what is that file? What is its extension? So this all is handled by the file management utilities. And you simply give the file name, no extension, but still the extension is given automatically by this. That is file management. File management also ensures access rights are maintained as part of the security and correct memory location allocations of the data when it is read from the hard drive or SSD and saved temporarily in the RAM. So this all is the file management. See, maintains file. By the way, what are directories? Directories are another word for folders. So directory is a term that is used in your CLIs and in your CLIs, and that is it. File naming conventions, the way I said, you simply give the file name and extension is given automatically. So this automatically is the control of the operating system. Where the file will be stored, where the file will be, how the file will be opened, how the file will be closed. If closed, then what actions are supposed to be performed. So this all is your file management. Okay, fine. And again,
Yeah.
access rights. Who has what kind of access to the file? That is also file management. Now, another very important feature is multitasking. So what is multitasking? Very simple. What is multitasking? Performing more than one task.
Multi
Hmm.
like it means you can do like more than one task at the same time.
And how is it being done? This is what we are learning here. We are revising, not learning as such. In reality, when we say multitasking, it is all possible because of giving equal time slice to all the running programs. Like for example, if there are three programs running, so all these three programs will be given equal time slice. And that is what memory management is, or what is multitasking is. For example, if the task one's time is over, then immediately the time for the task two will start. Then task two's time is over, then it is task three's time. And this is done so swiftly, so quickly that we as individuals, we as humans do not understand that there's much difference in that. So that is what, and again, multitasking is also handling that which program will be needing how much of the resource. So you can see the definition is allows a computer to carry out more than one task, and it is allowing this because of the equal time slice given to all the processes. Okay, and the moment the process time is over, then it is interrupted, and the next task will be in operation. And then again, definitely priorities are always there. Just remember, although we say multitasking, but in reality, priorities. If, for example, some task is running, and maybe some important task has come into the queue, has been entering the process. So maybe the current task will be halted, and the new task, which is a higher priority task, will be given the priority and will be processed, and then the continued task will be resumed a little later. So this all is again under the control of the operating system deciding that which task needs the immediate attention. Okay, fine. Next one is management of user accounts. And what are user accounts? For example, just giving an example to give you an idea, the way when we talk about the social media or talking about the web services, we all have user accounts. And these user accounts are simply helping us to give us the right to our own data. Like if I am using social media, so with the help of the user account or user IDs and passwords, I'm able to handle my resources. Same case goes with the operating system. The operating system also, like I may have different user accounts created so that every person is able to access his or her details. No two people are ever going to see each other's work. No two people will have the access to each other's work. So nothing bad is going to happen. That is what the management of user accounts is doing. And here you can see the role of an administrator. We cannot eliminate the role of the administrator. The administrator is keeping a track of all the people who are what is happening. What is happening? So that is what the thing is happening. Administrator is there. Slow. Administrator is there to oversee everything happening. Okay, so no person is ever going to misuse the resources. So this is just a diagram to make you understand that how it is all operational. So can you see this one? What is happening here? Now, can you see this one? This is just an example to make you understand. Maybe the person with the higher level security will be getting all the resources. The person with security clearance 2 is going to access level 2, level 3, and level 4. The person with clearance 3 will be accessing its level, and maybe level 4. And level 4, which is the least level, is only able to access its data, no other person. And maybe I can assume that the first level is an administrator. So an administrator, as the name implies, has equal right to each and every resource, or he is under the control of each and everything. So this is just a diagram to make you understand that you can access multiple resources, and maybe the person who is has the role of an administrator will be able to access each and everything because he has full control of each and every system, each and everything that is happening there. Moving to, again, a very important topic as far as examination point of view is concerned, again, running of applications. Acha, by the way, when you talk about the term booting up, what is booting up? And what happens when the
Like
systems are booted? Yes.
booting up is when you turn when the computer turns on and it starts up the start.
Yeah. The booting up simply means that when starting the computer, if I put it in the simple words, and definitely when the computer starts, so at the startup, there are certain things that are going to happen. And this routine is this routine of just checking each and every hardware component. This routine is checking the operating system is like the operating system is checking everything it was working properly, loading the part of the operating system into the RAM. This all is happening during the booting process. And this routine is handled by the basic input output system, or BIOS. In simple, we call it BIOS. And this handling, that to the moment you turn on the PC, again, the screen doesn't come immediately. It takes a little time. So this is called the booting time. And you can say that my system is booting up. And this booting up is handled by BIOS. And this is basically a type of firmware. And what is the definition of firmware? A program that provides low-level control of devices. So this BIOS is checking the presence of each and every hardware component. It's checking that each and every hardware component is functioning properly. And this all is under the control of BIOS. And this BIOS is a type of firmware. Again, hardware, software, firmware, and that is a program. And just you need to know the definition, because a 1 mark question can come in the paper talking about define the term firmware. So this is the definition: a program that provides low-level control of the devices. And low-level control of the devices mean something that is internally handled. Okay, may I move ahead? Now,
Yeah.
moving to where is BIOS held? Where is BIOS stored? And like that, definitely the thing can come in our mind that what is BIOS and where is it present? So here you can see BIOS is stored on a flash memory chip called EEPROM, electrically erasable programmable read-only memory. So again, this term that you simply need to know, that BIOS is stored on a flash memory chip called the EEPROM, and its task is to tell the CPU where the operating system can be found. Again, a little expansion, that what is it doing? It's holding where the operating system is. Is it present in the hard drive? Is it present maybe in a removable drive? Maybe it is present on a CD. So where the operating system should be loaded from, that is what is the task, is its task. Now moving to a little bit of the more discussion. Although BIOS is stored on EEPROM, which is electrically erasable programmable read-only memory, BIOS settings are stored on a complementary metal oxide semiconductor chip or CMOS chip. Now, just be clear, BIOS is stored on EEPROM, but BIOS settings, like for example, from where to load, that what are the values, like maybe hard drive or removable hard drive, or maybe some CD or anything, that is stored in the CMOS chip, and which is always connected to a power supply or the battery. And that is why the moment you switch off the computer and you turn it on, maybe the next day or maybe after 2 days, then you can see the same date and time, the right date and time is shown to you because of this CMOS battery. If the CMOS battery wasn't functional, then you need to enter the system date and time every time you are turning on the computer system. Okay? Now, what is else the user can do? The user is allowed to alter the factory settings by changing CMOS content, such as changing the clock speed. So this is what is under the control of the user. And this is what we talked about. Like, for example, remember overclocking we talked about. So this overclocking means that we are changing the clock speed. We are making it function beyond its capacity. Maybe we are trying to increase the FDE cycles. And this is done by changing the contents of the CMOS. Okay, clear about it?
Yeah.
Apps are also under the control of the operating system and need to access system software such as device drivers. Different parts of the operating system may need to be loaded in and out of RAM as software runs. So again, remember, like which part is supposed to be in the RAM, which part is not supposed to be in the RAM. So again, I talk about the VM, virtual memory system that we talked about, that is also under the control of the operating system. I mean, again, you can see the link that is being created between different applications, different topics that we have studied. So they all are interlinked. We talked about clock speed. Now we are learning that clock speed can be altered from here. Okay. Now, again, a very important topic of interrupts. Chimata, what is an interrupt? From real life, let's just talk about the real life first. What is an interrupt? Forget about the computer.
It, like for example, if you're doing something and something prevents you from continuing on to do something else.
Like maybe a knock at the door. You will excuse, that is an interrupt. Similarly, interrupt is a signal generated by the device or software. So just be clear about the main points. First point is signal. Who generates? Device or software. And when it is generated, by the way, when it is being generated, it is simply there to get the attention of the microprocessor, because microprocessor is is there to service the interrupt. So the moment some interrupt has happened, so the device or the software needs the resources, or it is going to generate an internal signal so that to the microprocessor so that it can process its request. And what will happen then? Again, you need to see either the processor will continue its task or it will stop momentarily to service the interrupt. That is dependent on the priority. Just be clear, some interrupts need immediate attention. So in that case, the microprocessor decides, then I mean, again, there are different priority levels. So microprocessor knows that which task needs immediate attention. So it will be interrupting the current task and will be servicing the interrupt. Or maybe some tasks may be a deferred one. So it's the operating system that decides that which tasks need to be serviced immediately and which tasks can be the deferred ones. Now, this is a very a very well organized talking about the cause of the interrupts, which you can see here, timing signal. This timing signal we have studied in chapter 3. Again, the same thing. All operations are coordinated by internal clock. If any operation is out of sync, doesn't match timing signals, then an interrupt is sent. Maybe some task is out of sync, is out of sync. So an interrupt will be generated, talking about giving the instruction or getting the attention of the CPU processor that there's some problem with the syncing operation. So timing signal is an interrupt. Input output process is an interrupt. Hardware fault. Now be clear, input output process and hardware fault are a bit different. User interaction, software error. Now let's talk about each of them. We have talked about timing signal, input output process. What is it? Interrupt can be generated when a hard disk drive or a printer, for example, are requesting more data. Now you can see requesting more data is not a problem. Like we are done with the printing process. Now printer is asking for more data. That is an interrupt. Okay, because it is wanting more data to be sent to it. Hardware fault. Then it can be paper jam, it can be printer out of paper, it can be the ink cartridge isn't there. So there are different types. Interrupt can occur, for example, if a printer has a printer jam or it runs out of paper or ink. So these are your hardware faults. User interaction, for example, if a user presses the brake key, and this means the signal will be sent to the microprocessor that something has occurred. So it will be definitely immediately processing the request that is sent because the pressing of the brake key. Last but not the least, again, software errors. Now, what are the software errors? For example, if an exe file cannot be found, that is one interrupt, software interrupt. The second one is two processes are trying to access the same memory location. That is going to generate definitely a problematic interrupt. And thirdly, division by zero. So again, a question can come in the paper talking about give three software errors. So then you will mention these three. The first one, exe file cannot be found. First software interrupt or software error, you can say. The second one is two processes are trying to access the same memory location. And thirdly, division by zero. Like, I mean, being a math student, you know that even in calculator, if you have entered a zero as a denominator value, then it generates an error in the calculator. So the same error is generated here also, and that is called a software error. So are you clear about these three?
Yeah.
And then these. You can see, figure out yourself. Hardware fault, this one is a problem. Definitely paper jam. It needs immediate attention. But talking about printer, waiting. Definitely printer is now asking for more. That is not a problem actually. Now, there's not a problem that is being faced by the printer, but simply it is doing its task. Now it needs more task. Like, for example, just like the student, if he has done the work, he says, Miss, I want more questions. So if he's done the work and he is asking for more questions, that is an interrupt. And again, another child can raise an interrupt in case he is not able to understand the question. That will also be the interrupt. So I guess this interrupt is now very clear. And we have already talked about interrupt priority, and we have said that it's the processor that is going to decide and service the interrupt. So once an interrupt signal is received, the processor either continues what it is doing or temporarily pauses the task in order to service the interrupt. The same thing. To determine the order of servicing interrupts, each interrupt is given an interrupt priority. So these are the key terms that need to be included in your answer if a question of interrupt comes in the paper. Okay, fine.
Yeah.
Now, another term before, I'll be talking about the term buffer also. But before I move to the term buffer, one more thing. If, for example, giving an example, for example, I was listening to maybe song, and then my phone bell rang. I was listening to the song from my mobile phone, and the phone bell rang. So what will happen? I will listen to the person who has made a phone call. So to the song, what happens? The song stops. Similarly, when we talk about the servicing of the interrupt, if interrupt has been received and the processor has decided to carry on with the new task, so definitely the current state of the task has to be stored somewhere, and that is called ISR, or interrupt service routine. The way I give you the example so that you can understand that when, for example, I was listening to the song, interrupt occurred, I listened to the person who has made a phone call, maybe a minute, and after the minute is over, the phone call has been, you can say, has been over. The song will continue from the same point where it had been interrupted. So this is all ISR. So same thing is here. Now the printer. The interrupt requests are given interrupt priority. The interrupt will then be serviced according to the priority using an ISR, or interrupt service routine. This allows the CPU to stop its existing task, service the interrupt from the printer or any other device, and then continue what it is doing by restoring the original task once the interrupt is cleared. So I've quoted you an example just to make the concept clearer of me listening to the song and getting the phone call, and it means it will be stopping the current task. Clear? Now, moving to another term,
Yeah.
buffers. What are buffers? Simple. Buffers are temporary storage locations inside the devices. And these locations, like the printer buffers, are needed so that the CPU, which is faster in operation,